Welcome, my name is Cyril, and today we'll be looking at likely Gaokao Physics question for 2025. Let's dive right into it. Question number 1 says, a satellite moves in a circular orbit of radius r around Earth. If its orbital speed is v, what is the period t of the revolution? And we know that the speed or velocity is equals to distance over time. That's to say that the speed in this case is same as saying I have what distance over my period. That is to say that the period is equal to my distance over my speed or velocity. That is to say from what we've already explained on circular motion, you can tell that the period therefore is 2 pi r over v. So look for the option that has what 2 pi r over v, and that is option A, which says that the period is 2 pi r over v. Moving on to the next question, question number 2, it says a conducting rod of length L moves with a velocity v perpendicular to a magnetic field B. What is the induced EMF between the ends of the rod? Now, if you look at this question, it's talking about a magnetic field. And we know that according to Sir Faraday, he said that whenever there's a velocity that is perpendicular to the magnetic field, he said that the induced EMF is equals to BVL, according to Sir Faraday. So look for the option that has what? BVL as the formula for getting the induced EMF, and that is option A. Moving on to question number 3, it says, in a Young's double slit experiment, increasing the wavelength of light used will cause the fringe spacing to dash. So in a Young slit experiment, we know that your fringe spacing is supposed to give us our change in d over d. What does this mean? It simply means that when there's an increase in the wavelength will lead to what? An increase in the fringe spacing, and that is because your fringe spacing is directly proportional to your wavelength. So because they are directly proportional, it simply means that an increase in one will lead to an increase in the other, which means that question number 3, the correct answer there is A. Moving on to question number 4, it says a point charge Q is placed at the center of a spherical conducting shell. The electric field outside the shell is dashed. Now, when a charge point is placed in a spherical conducting shell, that charge tends to move towards the center. So it is radially upward with magnitude according to Coulomb's law of. So the magnitude is going to be kq over r squared according to Coulomb's law. And that also follows Gauss' law of electric field. So the correct answer to that question is radially outward with magnitude kq over r squared, which is option B. Moving on to question number 5, it says a spring block system oscillates with angular frequency omega if the spring constant is k and the block mass is m. What is omega? And we know that our omega, which is our angular frequency in simple harmonic motion, your omega is equal to square root of your constant over m. So looking at our options here, so your constant over the square root of constant over your block mass will give you your angular frequency in your simple harmonic motion. So we'll look for the option that has this formula, which is option A, saying that my omega is equal to square root of k over m. Moving on to question number 6. Question number 6 says, when a gas undergoes an adiabatic expansion, which of the following remains constant? Which of the following remains constant? In an adiabatic expansion, there is no change in heat exchange. There is no change in heat exchange. So at that point, your Q is equal to 0 in adiabatic expansion. So the correct answer to this question is option C. Moving on to question number 7, it says a wire of length L and resistance R is stretched to twice its original length. Its new resistance is dash. So if we want to solve this question, we have to first find out what its new length is. And looking at this, we know that whenever a wire is stretched, the volume will remain the same, but its area will be different. So how do we find the area? We know that volume is equals to area times length. So if the volume is constant, it also means that when the area changes, so let's call this one A1 and call this L1. So if I have the wire stretched, so I have a new area which is A2 times its new length. And according to the question, they said the new length is twice the original length, which is what? 2L1. And we know that the volume is constant, which means that V1 and V2 are equal. So if V1 is equal to V2, this means that my A1 L1 is equal to A2 times 2L1. So this is the same thing as saying that my A2 is equal to A1 L1 over 2L1. So my L1 will cancel L1. It means that my A2 is A1 over 2. So it means that when the original length was twice after it was stretched, the area is now what? Half. And if that is what I have, I know that my rho is equal to RA over L. And I know that my conductivity is going to be constant. And if my conductivity is constant, this means that I have what? R1 A1 over L1 is equal to R2 A2 over L2. So the question is, what is the new resistance if the first resistance is R? So we're trying to find out what the new resistance will be. So if I make my new resistance R2 to be the sorry to the formula, if I cross multiply here, I'll have my R2 will be equals to R1 A1 times L2 over, this will give me L1 A2. So this means that my R2 is going to give me, my R1 is still R times my A1 is still A1 times my L2 is now 2L1 over my L1 is still L1 times my A2 is now A1 over 2. This means that my R2 is equals to, this will give me arrow A1, 2 arrow A1 L1 all over, this is divided by L1 A1 over 2. So this is the same as saying I have 2 arrow A1 L1 times 2 over L1 A1. So my L1 will cancel L1, A1 will cancel A1. It means that my R2 is going to give me 4R. So looking at our option, we're going to look for the option that has what? 4R. So, and that is option C. So you see here that what? That telling you that its new resistance is going to be what? 4 times the original resistance. So that takes us to question number 8. Question number 8 says, in a photoelectric experiment, doubling the intensity of light while keeping the frequency constant with dash. So whenever the frequency is constant in a photoelectric experiment, the kinetic energy will also double. Why? Because we have doubled the intensity. The intensity is directly proportional to the kinetic energy. So an increase in the intensity of light will also lead to an increase in the kinetic energy of the photoelectrons. So the correct answer to this question is option A, which means that what? Will double also the kinetic energy of the photoelectrons, which is option A. Question number 9, which is the next question, says two identical resistors are connected in parallel and then in series. The ratio of total power dissipated in parallel to that in series is dash. So we have tried to find what? The ratio of the power is in parallel to that of what? The series. So how do we do that? We have to first of all find the what? The total value of my resistors in parallel. So my resistors in parallel is supposed to give me R1, R2 over R1 plus R2. So this will give me, since the two resistors are identical, it means this is R squared over R plus R, which will give me R squared over 2R. So that is the value which can be simplified to become R squared, which is R times R, over 2 times R. So R will cancel R here. So it means that I have what? R over 2. So for my resistors in parallel, this is the total resistors. Total resistance is what? R over 2. And if this is what I have for my total resistance, it means that the power, so this is parallel, the power for parallel is supposed to give me V squared over R. And since they did not tell us the amount of voltage, and the voltage here is still going to remain as V, it means this is what I'm going to be having. I'm having what? V squared over, so my R here has become what? This is RP, so this will become what? Divided by R over 2, which means that my what? My PP is going to give me V squared times 2 over R, which is to say that my PP, the power in parallel, is supposed to give me what? 2V squared over R. So moving on, for series, my RS, which is what? Resistors in series, is going to give me what? R1 plus R2, and that will give me what? R plus R, and that will give me 2R. So the power in series is supposed to give me V squared over R. That's to say that I have what? V squared over 2R. So knowing this, and they're asking us to find the ratio of the power in parallel to that in series, it means I'm having PP ratio PS. And that is to say that I have what? My PP is 2V squared over R ratio V squared over 2R. This is the same thing as saying that I have 2V squared over R divided by V squared over 2R, which will invariably give us that we have 2V squared over R times 2R over V squared. So V squared will cancel out V squared, and R will cancel out R here. It means I'll be having 4:1. So looking at this, we're going to look at the option that has what? 4:1. So, and looking at our option here, the correct answer to this question is B, which is what? 4:1. So that takes us to question number 10. Question number 10 says, a ray of light passes from air into glass at an angle. What quantity remains unchanged? When light travels from one medium to another, the only quantity that remains unchanged is the frequency, because the frequency is from its source. So the frequency is unchanged, but the speed changes, the wavelength changes, even the direction of the wave is altered. But at that particular time, when light travels from one medium to another, the frequency remains unchanged. So the correct answer to this question number 10 is C. Moving on to question number 11. It says, a body is projected vertically upward with a velocity u. The time it takes to return to the point of projection is dash. And we know that whenever a body is projected vertically upward, the time it takes to move upward, time taken to get to its maximum height, is u over g. From projectile motion, we say that it's what? U sine theta over g. So since we are not talking about angles here, that's why I'm having what? U over g. But the time it takes for it to return to the point of projection is called the time of flight. And we know that our time of flight is equal to what? 2 time taken. This means that my time of flight, therefore, is 2u over g. So we look for the option that contains what? 2u over g, and that is option B. Moving on to question number 12, it says, in a Carnot engine operating between temperatures T1 and T2, where T1 is greater than T2, the efficiency is dash. So according to second law of thermodynamics, we know that the efficiency in a Carnot engine is given as T1 minus T2 all over T1. So this is the formula for calculating the efficiency in a Carnot engine according to what? The second law of thermodynamics. So that means that our correct answer to this question is option B. Moving on, question number 13, it says a particle of mass m moving in a circle of radius r with constant velocity v, the net work done over one complete revolution is dash. Now, because it is moving in a circle, this is what circular motion, and because it is a circular motion, it will be moving towards the center of the circle, and if it is moving towards the center of the circle, you'll be having something like this, which means that the angle between it is 90 degrees, and we know that the work done under centripetal force here is going to give me my FD cos theta. And if you look at the angle, because the angle here is 90, my cos 90 is going to give me 0. Force times the distance times 0 is going to give me 0. Automatically means that there is no work done. So the net work done by this particular particle is going to be 0, and that is option A. So the correct answer to this question here is option A. Moving on to question number 14, it says a coil rotates in a uniform magnetic field. The maximum induced EMF occurs when the plane of the coil is dashed. Now, when the plane of the coil is parallel to the magnetic field, this is when there is maximum induced EMF, as the magnetic flux is increased to the maximum when the plane is parallel to the magnetic field. So the correct answer to this question is option A, when the plane is parallel to the magnetic field. Moving on to question number 15, it says a concave mirror forms a real inverted image that is twice the size of the object. The object is placed dash. So they ask you, where are you going to place the object for a concave mirror to form a real inverted image that is twice the size of the object? You have to place the object between the focus, the principal focus, and the center of curvature. Whenever the object is placed between the focus and the center of curvature of a concave mirror, the image form is real, it is inverted, and it is magnified. So the correct answer to this question is option C. Moving on to question number 16, it says a positively charged particle enters a uniform magnetic field perpendicular to its velocity. Its path will be... Now, when a charged particle is placed in a uniform magnetic field, the magnetic field acts as a circular path. It forms a circular path such that the force that is present in this particular magnetic field becomes centripetal force. So its path is supposed to be circular. It's going to form a circle. So its path is going to be a circle, which is option C. Moving on, question number 17 says a body is thrown horizontally from a height h with velocity u. The time to hit the ground depends on what? Now, whenever a body is thrown horizontally, the time it takes for the body to hit the ground is always equal to square root of 2h over g. So this is the formula that we use for calculating the time it takes a body to hit the ground when it is thrown horizontally. And looking at this, you know that our g is a constant. So automatically, the time it takes for the body to hit the ground depends only on one particular factor, which is the height. So it depends only on the height, not even on the angle of projection, and not on the initial velocity, but on the height, which is option B. Moving on to question number 18, it says, which of the following statements about nuclear fusion is correct? Option A says it requires low temperature. Option B, low temperature and pressure. Option B says it releases less energy than fission. Option C says it powers the sun. And option D says it splits heavy nuclei. All of these are wrong except option C, because first, option A that says it requires low temperature and pressure is wrong. Nuclear fission does not require low temperature and pressure, and it also does not release less energy than nuclear fission. So, and it does not split heavy nuclei. Fusion is talking about combining smaller nuclei to form a larger nucleus. So, and you can only find nuclear fusion and it powers the sun. So it's one of the source of the is the source, main source of what? The sunlight. So what you get from sunlight is what? Nuclear fusion. So it powers the sun. That's option C. Moving on to question number 19, it says, when a convex lens is used to form a virtual image, the object must be placed where? So we are trying to find out where you place the object for what? A convex lens to form what? A virtual image. The virtual image is an image that is not real. So when you place the object between the focus, between the principal focus and the lens, the convex lens is going to form what? A virtual image. It's going to form an image that is not real when you place it between the focus and the lens, which is what? Option B. Moving on to question number 20. Question number 20 says, an AC generator increases the frequency of rotation. What effect does this have on the output? When the frequency of rotation is increased, the frequency of production of your alternating current will also be what? Increased. So there will be increase in frequency. So the frequency increases, frequency of production of the alternating current. So there's increase in frequency where there's an increase in the frequency of rotation. So if the rotation increases, automatically the frequency will also what? Increase, which is option B. Moving on, question number 21 says, in an RLC series circuit at resonance, the impedance is dashed. An RLC circuit is a resistance, an inductance, and a capacitance circuit. So we have the capacitor, the resistor, and the inductor within this circuit. So when you have that, it means when they are at resonance, it means that your capacitive reactance is equal to your inductive reactance. So when your capacitive reactance is equal to your inductive reactance, it means that that particular circuit is at resonance. And ordinarily, I'm supposed to be having your resistor plus your capacitive reactance plus your inductive reactance to form my total impedance. And if this is what I'm having, since these two are equal, automatically means the only thing that is present in the impedance is what? My resistance. And if only resistance is present, so automatically our correct answer to this question will become what? Option C, which says that what? My impedance is equal to my resistance only. So that takes us to question number 22, which says a projectile is launched at an angle of theta with the horizontal. The range is maximum when theta is dashed. So at what angle is the range maximum is what they're asking us. And we know that the range in a projectile is u squared sine 2 theta over g. So these are formula for calculating the range in a projectile. So at what angle is our range maximum? Our range is maximum when the angle present in this particular projectile is 45, because if I have, this will give me u squared sine 2 open bracket 45, so over g, which is same as saying what? U squared sine 90 over g. And we know that sine 90 is 1, which is the highest amount of value you can ever get for a sine. So when it is at 1, when my sine is going to give me 1, you are going to get what? Maximum range, which means that the angle of projection of this particular projectile must be what? 45 degrees, which is option B. Moving on, question number 23 says, a gas expands isothermally. What happens to the internal energy of the gas? When a substance, for example, a gas as in this case, expands isothermally, it means there's no change in the what? Thermal energy. So in the internal energy, there is no change. When there's no change in the internal energy, it means that the what? Internal energy of the gas remains constant, which is what? Option C. So the internal energy of the gas remains constant. Iso means what? No change. So moving on to question number 24, it says a wire carries current. The magnetic field at a distance r from the wire is proportional to what? So this question is based on Ampere law of the magnetic field. Ampere law of magnetic field, where he said that the distance is equal to mu naught I over 2 pi r. Mu naught I over 2 pi r. So they're talking about what? In this case, since current is present and your mu naught is a constant, this is the same as saying that I have what? I over R. So we are looking for the option that contains this particular formula. So looking at this, our correct answer to this question is option C. Moving on, question number 25. It says, in simple harmonic motion, acceleration is maximum when dash. Acceleration is maximum when the displacement is maximum, because we know that our acceleration is minus omega square x. So when the displacement is maximum, when there is a maximum increase in the displacement of that particular body, then there's what? Maximum what? Acceleration, as acceleration is directly proportional to your displacement. So the correct answer to this question is option C. So moving on, question number 26 says, when light travels from water with refractive index 1.3, so we have the refractive index of water as 1.33, to air with refractive index 1. The total internal reflection occurs if the angle of incidence is that. So in this question, there's an omission there. There's supposed to be when light travels from water. So that part of it is not there. So we are looking for the total internal reflection. What happens to the total internal reflection when light travels from water to air? Because water is a denser medium than air, so the total internal reflection is going to be greater than the critical angle. So when light travels from water to air, which is less dense than water, there's going to be what? A greater critical angle. The total internal reflection is going to be what? Greater than the critical angle. So in this particular question, the correct answer to this question is option B, which says that what? The total internal reflection will be greater than the what? Critical angle. So moving on to question number 27, which says a transformer works on the principle of dash. A transformer works with the principle of electromagnetic induction, where it converts your magnetic field to induced EMF. So your transformer converts what? Your magnetic field to induced EMF, which is the principle of electromagnetic induction. So the correct answer to this question number 27 is option B. Moving on to question number 28, says in a nuclear reactor, the function of the control rod is to dash. What does the control rod do in a nuclear reactor? That's the question they answer. Option A says it increases the temperature. Option B says it slows down the neutron. Option C says it absorbs excess neutrons. And option D says it shields the radiation. The correct answer to this question is that it absorbs excess neutrons. So your control rod absorbs excess neutron in a nuclear reactor. Moving on to question number 29, it says a charged particle moves in a circular path in a magnetic field. Doubling its speed will cause the radius of its path to dash. So we know that the radius of the path in a circular, in a magnetic field is equals to mv over qb. So this automatically means that the radius of a magnetic field, a circular path in a magnetic field, is directly proportional to the speed. So if anything happens to the speed, automatically it is reflected in the radius. So if the speed is doubled, so we are doubling the speed. If you double the speed, automatically the radius will also what? Double. So the question is, doubling its speed will cause the radius of its path to what? Double. So the correct answer to the question is B. So the radius will also what? Double. Moving on, question number 30. It says the half-life of a radioactive substance is 10 minutes. After 30 minutes, what fraction remains? So we know that since the half-life, T half, is 10 minutes. And then they're asking us after 30 minutes. After 30 minutes, it means you've gotten 3 half-life. So my T half is now what? 3. So I've got to what? 3 half-life. And I know that the fraction remaining is equal to 1 over 2 raised to the power of your number of half-life. So your number of half-life, 1 over 2 raised to the power of the number of your half-life will give you the what fraction that remains after a particular period of time. So this is the same as in I have what 1 over 2 raised to the power of what our number of half-life here is what 3. So this will give me what 3, and that will give me what 1 over 8. It means that after what 30 minutes, I'll be having what 1 over 8 of this particular radioactive substance remaining, and that is option C. So we've come to the end of today's class. If you have a question, drop it in the comment section. Don't forget to subscribe and turn on your notification bell so that when we drop more videos like this, you'll be notified. Thank you.